Hello everyone. So today we'll be looking at the program for interfacing four 7-segment display panel to display using serial and parallel out shift registers. For same, I'm using Keil version 5 and Proteus 8 Professional for the coding and simulation part of it. Here I have included two header files, register 51, which holds the basic functions of the microcontroller 8051, and KGC serial, which facilitates in the serial data transmission and reception. So here I have given serial data in port 2.0 and I have given clock pulse in port 2.1. I have also declared two functions, byte split and character split, which I'll be explaining with the flow of the program. So moving on to the main function, I have declared two integers x and y and have set the timer and the scon here, and the timer is set in mode 2, which is the 8-bit auto reload mode, and we start the timer. So P2 is initially 0, which means the 7-segment displays are set to 0. Now while the condition is true, or we enter into an infinite loop, that and here the user enters the first byte, that is, which will be stored in X, and the user enters the second byte, and which will be stored in Y. We display them using this byte to PC of X and byte to PC of Y. X, which holds the upper nibble, and Y holds the lower nibble, respectively. Then we call on the function character split Y. Why I'm sending here Y in the first, because this gets pushed in like a stack. It's so the lower nibble goes in first, and then the upper nibble gets in first. So first I call on character split of Y. The control transfers to this function character split, and Y is transferred into here, the value of Y. Also here I have declared two characters and an array which holds the value from 0 to F, hexadecimal values. So here basically the nibble which we send away from here gets the 8-bit data gets split into 4-bit data, that we get it into two 4-bit data, so that we can facilitate in these two parts. So what happens here is we initialize each of these separately, and we give the same value of the bind. Suppose, for example, we give the value as D1. Suppose Y had the value of D1, which is 11010001 in binary. What happens is we shift the value of M to the left 4 times. So this particular nibble comes to the upper nibble, and this entire thing goes out, which will be replaced by zeros. Now since we need this one, now this has become 1 0. Now what we need is 1 on the lower nibble, so we push it again, we shift it again to 4 times to the right, and now it is 0 1. And I have called another function byte split of V of n. So it will go to the first one over here. So suppose m is 0 1 right now, so 0 1 will be transferred to here, and this particular thing will be transferred to the byte split. Same thing with this one, where I have given the same assignment of byte as D1. Here we try to extract the upper nibble separately. So we right shift it 4 times, so we lose this entire part of the 8 bits, and we are left with 0D over here. So here 0D gets transferred into byte n, and it is called sent, and the function goes to byte split. Here individually, like we take first A of M. So individually it comes here, and this is where we will be assigning the value, these hexa values to it. So here I've declared I for the loop iteration, and I've declared a character variable X, and I've given the value of this particular value over there, and have also declared a temporary character. So now here in the temporary character is initially assigned with X. So for example, let us take 5b from here. So when I'm sending 5b, it is 0101 1011 in binary. So it will be stored in X. So the value of X will be stored in temporary variable. Now suppose what I do here is I right shift T to 7 times. So this entire part will be removed and only this part will be sent into here. Now this is 0, 0. And then the X is left shifted 1 time. So this particular this particular bit is transferred out and taken out, and then we have transferred it to this here. So we get 0. So this 0 we have taken it out, and then we have passed into the serial data and then we have given clock pulse of we on it and off it. So there is a clock pulse in there, and we iterated 8 times so that each and every character of this is being taken out. Now as you have observed, we are taking the foremost part of this one. Like after each time this part will be getting removed. After the 8th iteration we'll be left with just this much. So why we do that is because the value goes from 8 A to G in the leftmost direction in like a stack, and we send the lowest nibble first inside. So this will go as A, B, C, D, E, F, and G. So that is why we do it. We are shifting it 7 times, and so that is how we get the first. So this will give you one value into this particular cell, and then again when we send an A of n, the same iteration happens, and then we get this part of the number, which means the register will keep shifting it to the last nibble over and over, and then we go back. Once this two are executed, it goes back to the main function and calls out X. So here now X is again transferred to character split, and then it is split into 4 more bits, and which will be passed on to byte split, and so we get the remaining 2 parts of the display. Now let's look at the simulation part of this one. I've already created hexa file, and so here let me just explain you this one. This is the 8051 microcontroller, and I have set the serial data transmission here and the clock pulse from here, that is port 2.2 as SDA and port 2.1 as clock. Port 3.0 and 3.1 will act as the transmission and reception to the virtual terminal. Here we have the shift registers, which is serial in and parallel out. So as you can see, they are connected in series, and parallelly we get the output. So Yeah. So we send the serial data through the A and B port of this registers, and we give the clock pulse. So the first bit of data comes in here, and just once it overflows, it goes back to this one, overflows and goes to the next register, and finally drops on the last register. So like this, first this register which is connected to this particular 7-segment display will be displayed first. Then this register, when it is overflowed, it will come to this one. This register is connected to this one, and finally the last and the upper nibble will be dropped over here. So let's see the working of this. We enter the first byte. Let's see. 1, 2, and then we give A, B. So as you can see, the first two, the lowest nibble, that is B, is being sent first, and then the A comes in, and then the upper nibble, that is 2 and 1, drops later on. So when we give BCD, it's the same thing. Thank you.